All right, so today we have number 921. Minimum add to make parenthesis valid. A parenthesis string is valid if and only if it is an empty string. Very simple. It can be written as AB, A concatenated with B, where A and B are valid strings. Or it can be written as A, where A is a valid string. Okay. Uh, you are given a parenthesis string S. In one move, you can insert a parenthesis at any position of the string. For example, okay, you can insert it or close your parenthesis, return the minimum number of moves requires. All right, so the description is a little bit chaotic, in my opinion. Um, it's easy once you understand it, but right now it's not. Let me actually like move. I don't know if my webcam is like in the middle of the. It's whatever. Um, just leave it there for now. We can figure it later. All right. So what does this mean? Basically, what this should say right at the beginning is that every single letter in our string is going to be open or close parenthesis. So basically what they're trying to say is that this, and then you have a string A inside of it, and then this is closed. And if A is a valid string, then all this is valid. So you can concatenate how many parentheses outside as much as you want. Okay. And also if this happens and this happens, this is fine because A concatenated B, so this is A and this is B, is a valid string. And we can also do this because this then is going to be considered like a full string, and in this case is correct, right? So basically it's saying as long as there is a like a valid string, like you can concatenate as many valid strings you want, and you can also wrap around parentheses on valid strings. That's basically what it's saying. Or simple, the string is empty and then it's valid. So our objective of this method is to find the minimum numbers of moves required to make S valid. Okay? But I really don't, I think this is a little bit misleading. I think we should read this as how many parentheses are not valid, like they are not gonna be closed um, inside our string. That's simple, okay? For example, let's see our examples. Let's say first input, we have, actually gonna draw it. Oop, bind, let's do a better parenthesis. Okay. I think this was on the left side, but it's whatever. Just understand my point. This, it's a valid parenthesis, like open and close. So we remove it, okay? And now we have just one parenthesis. And this is going to represent how many moves we need. We need to insert just one more parenthesis to make it right. So we return 1, okay? Let's do the other example. It was just 3 open parentheses, right? And we cannot remove anything because there's not a valid string, right? So what do we have to do? We have to add 3 parentheses, okay? So we return 3. Let's remove everything. Boom. All right, let's come back to our thing. How are we gonna um, solve this algorithm? So basically we just need to do this. we need to use an data structure called stack. I'm pretty sure you're already familiar with stacks, but just to like mention them how they work, it's just basically something like this, right? So what does a stack do? When we insert an element, we're gonna always insert it at the top of the stack. Okay. So here we have our element E. When we call our function pop, okay, we get the last element. So we get E, and then we remove E. Or we can do seek, where seek doesn't remove our element, but it will look at it. And I think this is push. Okay. So we have basically just three methods we can call. And this is pop, removes the last element introduced and returns it. Seek returns the last element without removing it. And then push puts the selected element we want to push. Here we have element E on top of the stack. That's it. So what we can do, we have basically our string here of parentheses, right? Okay. If we get a parenthesis open, okay, we push it in the stack. And then if the next one, okay, if the next parenthesis is a closed one, then we remove both. Okay? And we just do this for every single element in our string. And then we are left with all the elements that weren't valid. And we return basically the size of our stack. So let me clear some stuff out. And I'm gonna show you a demonstration. Let's have our string is equal to open, open, closed. Something like that. Something very simple, right? And then our stack, we have our stack here. Can I do shapes? I don't know how to do shapes. Oh, so sad. There's probably a way to do shapes with this tool, but my handwriting is immaculate. So, how are we gonna do this? So the first element is an open one, right? And so we push it to our stack. And so we create a little thing like this. We push our little parenthesis inside. Then we go forward. Is peak, right? Is peak or our stack a closed parenthesis? Sorry, an open parenthesis? Yes. But the next one is not a closed one. So we push, okay? We push the other one. Now we're gonna go and peek our stack. We're gonna retrieve open parenthesis, right? And we're gonna check if the other one is how you say it in our string, if this one is a closed. Oh, it's a closed, so we remove this, okay? And so we're left with just one open parenthesis, and this is gonna be what we return. We return in our method, we return stack.size. Okay. And this will solve us the problem. So let's write it right now. So we have to initialize a stack. I have to initialize a stack in Java. It's like this. We need to use the wrapper class of the character class called char. So char is the primitive data type. Okay. So we use the character class or wrapper class for the char. And then we're gonna call it stack is equal new stack. And then in Java, we don't need to itemize afterwards if we have optimized initially, right? Then we need to create our array of characters. We don't have to create our array, but I think it's just so much easier to just do chars, yeah, chars. I don't know. Okay. As to char arrays, then is there something I have to do? No. Let's start with the for loop. I can do a for each, I believe. So char c into chars. All right. So what we said first, we said that if. So what are the conditions to remove? Let's write this if statement. What are the conditions to remove the parentheses? So first of all, we need the stack to not be empty, because if stack dot is empty, so this is not null, has to be. So if the stack is actually full, it's populated with at least one element, and stack dot peak is equal to our character open parenthesis, right? Okay. And if our character C, which is a char C, is equal to what? Closing parenthesis, then we pop stack.pop. Okay? We pop our element. Else, we add the element to the stack. Okay? That's it. That's our algorithm. And then we basically just have to return stack.size. Very, very simple. Okay. Let me see. Stack. Looks like everything is right. Peak is not a, it's a method. So let's use it. Let's call an actual method, right? All right. Let's try some test cases. There's a guy with test cases here. Boom, boom, boom. All right, let's run this test case. Yay, got it right. And that's it. I feel like this is not a medium, honestly. I think this is most likely an easy problem. Maybe you can think about it as a medium if you really don't understand like the assignment, because the assignment pretty what? Huh. Very interesting. I did it already, but I was getting, oh, I still, wait, no, 1 millisecond. Yeah. What's the difference? Stack character, if it's empty, stack p, pop, else push is the same. I wrote it the same way, right? Stack and empty, and stack dot peak and c equal. Maybe because I'm streaming, it's slower. Maybe that's probably the thing. Yeah, same code, but 1 millisecond slower. It's fine. It's not a thing. Hello, I am Kin. Welcome to the stream. So yeah, that's about it. That's the video for today. I'm gonna post it on YouTube, and hopefully maybe make some shorts and explain stacks to people about this. Layout one updated. Okay. All right, everyone. Thanks for watching. That's the end of the video. And check check my YouTube channel to see other problems like this. Have a good one. Peace.